Hello there, welcome back guys. Welcome back to a brand new video of Mighty Ghost Hack YouTube channel. So guys, this is the second video. First video I already uploaded on coding interview playlist. So in this video we are going to looking into the similar question which we saw in the first video. If you haven't checked out that video, I will recommend first check out that video, then come to this video, so it will be better for your understanding. So in this video the question is little bit similar. The earlier video what we have done, we have find the average of a continuous subarray, but in this video we will find the maximum sum of continuous subarray with the size k. Now let me first explain you the problem statement here. Let's understand first it by the inputs. So consider this is the array which is given to us. Now the question is we have to find the maximum subarray and we have to return its sum. So the maximum subarray we have to find and we have to return the sum, and that subarray should be the length of k, and here length of k is given as a 3. Now let's try to understand the problem more briefly. So k is given as a 3, then we will find this. Now we will go to the each subarray with the size k and we will sum and check if it is a maximum or not. Let's see 215, the length of 3 subarray. So 5, 6, 7, 8. So maximum. So right now we got sum as a 8. So we will store in one of the variable. Then the next 151, 5, 6, 7. So it is not greater than the sum which we have. Then again we move further, 5, 1, 3, 5, 6, 7, 8, 9. So we have 9 as a new sum value, and which is the greater than the previous sum. So we will simply change the sum value, max sum value 8 to 9. Then again we will look further, 1, 3, 2. So 3, 5, 6. Obviously it is not the maximum one. So by doing subarray sum, we got 513 is the subarray which sum is 9 and which is maximum. Now let's understand the second example. Here k given as a 2. If you see 3 and 2, it should be 5. Then 3 and 4, 7. So right now we can mark as a 7, 4, 1, 5 and 1, 5, 6. So the max subarray should be 3 and 4. So the maximum subarray is 3, 4, and we will return its sum. Now let's understand the coding structure, the problem statement. So let me run this file. Okay. So this is the input, we have array and the k size given as a 3. This is the single function where we write our logic, and this is the way to print the output. Here I am calling that function and passing the array and the k value. Now let's understand the logic what we return. So for iterate over all the variable, here I write the single loop which will go till the array length. So 2, 1, 5, 1, 3, 2. It will go till array length. Then here I added the minus k. Here if I did not add the minus k, then output should be the different. You can see the output is coming as a NAND. So why this happened? This happened just because we have k as a 3. First we will iterate over this one, 2, 1, 5. Then 1, 5, 1. Then 5, 1, 3. Then 1, 3, 2. Till 1, 3, 2 we have array. But apart from that 3, 2 and later on we don't have any element. So it should be take null as the value. Then 2, 1, etc. So there is a no value available. That's why we need to add the minus k. So it will stop at the 1, 3, 2 subarray. So this is what the single loop we have. And for storing the value, so here I added two variables. First is a max sum. Whichever sum we will get for each iteration, we will add here. Then window sum is basically for 215 I will store in the window sum. For 151 I will store in the window sum, and 513 I will store in the window sum similarly. So when the I is 0, the window sum is 0. Now this is the inner for loop. So it is basically help for the iterate over the length of k variable we have. So when I is 0, then it will iterate over the 215. When I is 1, then it will iterate over the 151. So how it's working? If you see j equal to I. So if I is 0, then j is 0. That is fine. So j equal 0. Then j is less than I plus k, which means j is less than 0 plus k value we have is 3. So it will iterate over the 3 times 0, 1, 2. So at the 0, 1, 2, 0, 1, 2, what we have 2, 1, 5. Then again I is getting increment. Then here I is 1. Then this condition should be 1 plus 3. It is a 4. Then again it will iterate over the 3 element only. But in this case array of j is like 1, 5, 1 similarly. So whatever value we will get 1, 5, 1, and when I is 0, 2, 1, 5, when I is 1, 1, 5, 1, when I is 2, 5, 1, 3, whatever value we will get, we will add in the window sum. Once this sub array value we will get the window sum, we will add the max logic. So here first time max sum is 0 and window sum is we got 5, 1, 6, 7, 8. So it will store the 8. So similarly for 1, 5, 1, what we will get 5, 6, 7, 7, 7. Obviously max sum should be the 7. Then here 5, 6, 7, 8, 9. So earlier we have 7 and window sum is 9. Then obviously the max sum it should be the 9. And once every iteration is done, whatever max sum we have is 9 obviously that we will return, and it will simply store in the output and we will simply consoling the output. So in this solution we are iterating over each element. So in order to optimize this solution, how we can optimize this solution? If you look at into this scenario, what we does, first we will take these 3 element, then we will take this 3 element, then again we will take this 3 element. So instead of that, what we can do, first we will take this element, then in the next iteration we simply add this one here and we will simply subtract this 2 from here. So what we will get, we will get 151. Then in the next iteration we add the 3 and again we minus the 1. So this approach is nothing but the sliding window approach. So I already mentioned the sliding window approach in the blog as well. You can check out this blog as well. Now let's understand this part as well. Let me open the sliding window solution. Let me run this one. Okay. Now if you see, the input is similar for our understanding and the k value is also similar. This is the function. This is the way to print the output. The logic change over here in this function only. So first, like similar max sum we have, that will be stored whole max value. Then window sum we have, for every iteration sum we will store in this window sum, and window start we have. This window start is basically help us to use the sliding window approach. So how this will help you? So for the first iteration window start we have 0. So 215 we will get the sum, and once even before that end of the loop we will increment this window start. So what it will does, it will simply subtract the previous value. So it will subtract this one, then again next iteration will happen, then again the previous value will subtract with the help of the window start, and this value we will add. Now let's understand this condition. So here window end, this is the variable I am taken as a window end as 0, and window end should be loop over the array of length. So 2 1 5 1 3 2, in this case it will iterate whole array of length. So this is just a iteration loop. And inside, so first window end is 0, so if I will add array of windows 8 which is 2 in the window sum, and here is the logic. Here I will check is window end is greater than or equal to k minus 1. So first we have window end as a 0, and here condition we are checking greater than or equal to k minus 1 which is 2. So 0 is greater than or equal to 2, no, then again this will not execute, then again window end should be 1. So 1 is greater than or equal to 2, no, then again this will skip, then array of end 1 value is 1 actually, so the whole sum, so the whole window sum is actually 3. Okay, suppose now for the next iteration windows end is 2, so array of 2 is basically 5, so 5 and 3 previous value, it should be 8. So 2 is greater than or equal to 2, yes, then this condition will be true. Now here what will happen, we will compare. So max sum what we have is 0, and window sum what we have is 8, then obviously max sum value should be 8. So once max sum value is initialized as a 8, so here in this condition we will use the window start, which is basically helps to subtract the previous value. So array of window start which is 0, so 2 will get minus. So for the next iteration we will perform on the 151, and for the again next iteration we will perform on the 515 by subtracting the previous value. So once we got the maximum value, that will store in the max sum, and that will be written and we will print here. So this is what the sliding window approach, which provide us the better approach with the ON time complexity. So guys, this is it for this video. I would suggest please check out this blog as well. I will provide this link in the description. So we will meet again in the next video. Till then, bye.